Hello everyone, it's great to see you all back here for training day 2 with akaBot team. From the last lesson, we explored an overview of RPA, an exciting step into the world of automations. Today, we are diving deeper. We'll uncover basic concepts of RPA and learn how to work with data variable in akaBot. These foundation skills are critical for creating automation workflows that are smart, efficient, and tailored to your needs. Before we get into the technical details, here's a quick roadmap for today's sessions. First is the basic concept, which will introduce you to key concepts in akaBot. Next is the data manipulations, where we will learn to create and manage variables effectively, making your automations workflow more dynamic. And by the end of these sessions, you will understand and get used to the basics of akaBot. Let's dive into the first lesson of today, variables. What are variables? Simply put, variables are containers for data. While the stored data can be changed, each type must remain consistent. Variables have four main properties. First one is name. This is the variable identity. It should be clear and straightforward, related to the content it contains. Next is variable type, which defines the kind of data the variable can hold, like text, number, date, or arrow. For other types, you can explore additional options using Browse for Types. A scope determines where the variable can be accessed. Keeping the scope small ensures better clarity and avoid conflicts. Last one is default value. It will specify the starting value of the variable. Types of variables. akaBot supports different data types to help with all your automation needs. Types of variables. akaBot supports different data types to help with all your automation needs. Let me explain each one. First, we have string, which store text like hello or automations. It's great for working with names, messages, or any kind of words. Next is Boolean type. This is used to store true or false value, perfect for making decisions in your workflows. Then there is number, which can store whole number or decimals. It's useful for calculations or anything with number. To store with date and time values, we use datetime variable. And if you are working with data in rows and columns, data table is the right type. It helps organize and process table-like data. For more flexibility, object is an all-purpose type that can hold any kind of data you need. And lastly, there is file, which links to files in your system. It's great for handling documents or file-based workflow. With these types, akaBot makes it easy to handle almost any kind of data for your automation tasks. Let's talk about how to create variable. akaBot Studio gives you three different methods. From the variable panel, you can use the create variable option to add a new one. A quick Ctrl plus K shortcut from the property panel or the body of the activity can open a naming panel to set a new variable. Each method is flexible, so you can choose what works best for your workflow style. Once you have created a variable, you can set a value using an assign activity or remove it when no longer needed straight from the variable panel. Effective variable management is the key to building clean and effective workflow. The next topic is argument concept. Arguments are similar to variable. They both represent values. However, the key difference is that arguments allow data to be transferred between workflows, making them ideal for building modular and reusable components in akaBot. Arguments contain the same key property as variable, such as name, type, and default value. What sets them apart is a direction property, which defines how data flow. In argument pass data into the workflow but cannot send data back out. In contrast, out argument pass data out of the workflow but cannot receive the data. And in out argument can transfer data both ways, allow flexibility within and across workflows. By using argument effectively, you can create workflows that are more dynamic, connected, and reusable. Now, let's talk about the invoke workflow fly activity, your tool for working with argument. Here how to set it up. From the activity panel, there are first workflow part, where you will specify the file path of the invoke file. Next is edit argument. It's a button where you can click to add and edit different types of arguments. Next is a button import arguments. You can import more arguments in this field. On the property panel, there are options continue on error. It is a decision if the automation should proceed after encountering an error. Next is a display name. It's the name of this activity. The checkbox public is used for if you want to the activity data to appear in the log. And the last one is a workflow timeout. It's the amount of time to wait for the activity to run before an error is thrown. Let's talk about the process structure of akaBot, which is designed to provide a clear, organized, and efficient framework for building automation workflow. In process structure, there are three predefined types: the sequence, the flowchart, and the state machine. Sequence. A sequence is a container designed for simple, linear workflow where activities are executed one after another in a predetermined order. It is best used for the straightforward process with minimal complexity, like workflow that involve simple activity and only a few decision statements. And sequence help keep things clean and easy to follow, making them perfect for basic automation tasks. Next one is a flowchart. A flowchart provides a clear, visual representation of the workflow you are building. It is highly versatile. You can use this for a wide range of activities, from small tasks to large, complex projects. What's more, it can easily be reused in other projects if needed. Starting from the Start button, you can add activities step by step to design your workflow. Flowcharts are especially useful for complex logic that involve multiple decision statements, connectors, or loops, making them ideal for handling detailed and dynamic automation process. And last one is a state machine. A state machine is a type of automation designed to handle workflow using a finite number of states. Here's how it works. The machine enters a state when triggered by an activity. It exits that state when another activity is triggered, moving to the next step. An important feature of state machine is transitions, which define the conditions for moving from one state to another. These transitions are visually represented by arrows or branches connecting the state. A state machine consists of three key parts: an entry execute operation when entering a state, exit execute operations when leaving a state, and transitions define the condition and logic for moving between states. And the state machines are ideal for handling complex conditions that require focusing on specific state and event, offering precision and control in dynamic workflow. Then we move to control flow in akaBot, which ensures your workflow execute tasks efficiently and logically. Control flow is categorized into two main types. The first one is decision-based control flow. This allows certain actions to be executed on a specific conditions. For example, Using an if activity or a switch activity, you can direct the process to follow different paths depending on whether certain conditions are met. It's perfect for handling scenarios where different actions are required depending on the data or situations. The second type is the iterations-based control flow. This handles repetitive tasks by looping through a set of activities multiple times. A common iteration tools include for each, while, and do while activities. This is used when you need to process lists, collections, or repeated actions until a specific condition is satisfied. Decisions-based control flow. As mentioned above, it is where your workflow gets the power to make decisions and follow different paths based on conditions. First, we have the if flow decisions, which are similar to a simple question with two potential outcomes. If the answer is true, the workflow will execute the step in the then branch or follow the true arrow. If the answer is false, it will check the else branch or the false arrow. This is perfect for a straightforward decisions where you only need two outcomes. Next, we have the switch and the flow switch. This is a bit more versatile. It's like asking a question with a multiple possible answer. You start with the conditions. It could be something like, what is the payment method? If the condition matches one of the predefined cases, say it will be credit card or PayPal, the workflow will execute the step for that specific case. But what happens if none of the case match? That's where the default case come in. It will ensure there's always a backup plan. Now, let's move on to the iteration-based control flow, which help you manage repetitive tasks by looping through actions multiple times. There are a few different types of loops. First, we have the while loop. This loop checks the condition before each iteration. It will only execute the action inside the loop if the condition is met. So if the condition is false from the start, the actions won't run at all. Next, there is the do while loop. This one works a little differently. It will always execute at least once, even if the condition isn't met initially. After the first run, it checks the conditions after each iteration. The loop continues until the condition is no longer true. Lastly, we have for the if loop. It is used to iterate through a collection of items, such as a list or an array. For example, if you have a dataset, the for each loop allows you to go through each element and perform an action on it individually. There's also a specific version called for each row, which is used exclusively for iterating to each row of a data table. Moving forward, let's explore advanced control flow, which gives you even more control over how your workflow behaves. Delay activity is simple but powerful. It pauses a process for a specific period of time. Sometimes you need to wait for a certain event or condition before continuing, and the delay activity is perfect for this scenario. Next, we have the assign activity. It is used to allocate value to variables or arguments. Whenever you need to store or update data in your workflow, the assign activity allows you to set or change value, making your automations more dynamic and adaptable. Then we have break. This activity allows you to complete exit a loop at any chosen point. Once the break is triggered, the loop ends, and the workflow continues with the next activity. It's useful when you want to terminate a loop early, saving time and resource if a certain condition is met. And finally, there's continue. This activity allows you to skip the current iterations of a loop and continue with the next item in the collections. For example, if you are processing a list of data and encounter an item that doesn't meet your criteria, you can skip it and continue with the next item, keeping the workflow running smoothly without unnecessary steps. Let's now shift our focus to data manipulation, which is all about transforming information to make it more organized and easier to work with. Data manipulation involves several key operations. First is retrieving information. This refers to extracting specific entries based on certain conditions. You can filter, summarize, or pull out information that meet particular criteria, making it easier to process. Next, we have adding entries. With these operations, you can insert new elements into a data structures. You can even apply conditions to ensure only filter items are added, keeping everything organized. Then we have deleting items. At times, it is necessary to remove particular entries. These operations allow you to delete elements from a structure based on specific criteria, ensuring the set remains clean and relevant. Lastly, we have modifying value. This involves changing the existing item within your structures. You can update values, change format, or perform other operations to adjust the information for better usability. By mastering the manipulation technique, you can effectively manage and adjust your informations to fit the needs of your automation workflows. Now, let's take a look at some essential string manipulations methods. Starting with content, this method checks whether a specific substring exists within a string. It will return a boolean value true if the substring is found, and false if it's not. For example, this will check if the word text is presenting in the string str_var. Next, we have a function replace, which allows you to replace or occurrence of a substring in a string with another substring. For example, str_var replace original replace will replace every instance of the word original in str_var with the word replace. Then we have function split. This method splits a string into an array of substrings based on a given separator. So if you have a string like str_var.split, it will divide the string at every pi symbol, creating separate elements for each part of the string. Lastly, we have toString. This method is used to convert any data type to a string. For example, if you have a number stored in an integer variable, you can use inNumber.toString to convert it into its string representations. And you also can find all the necessary methods at the below reference. Let's dive into the collections manipulations. There are three different types of common use collection in akaBot: array, list, and dictionaries. First, we have arrays. Arrays are used to store multiple values of the same data type. When you create an array, its size is fixed, meaning once it's set, you cannot change how many elements it holds. The values inside an array are stored in order, and each item can be accessed using an index. For example, if you have an array like array first name, middle name, and last name, you can easily access each name based on its positions in the array. Arrays are perfect when you know the exact number of values ahead of time, and this number won't change throughout the executions of your automations. Next, we have lists. Lists are similar to arrays but are much more flexible. You can add, remove, or modify the item in a list during executions, making it dynamic and growable collections. Like array, the values in a list are stored in order and can be accessed by their index. For instance, you may have a list like list mail message, where each entry represents a different mail message. Lists are ideal when the number of data value is not fixed, and you may need to change the size during the process. Finally, let's talk about dictionary. Unlike array and lists, dictionaries store data in pairs. Each pair consists of a key and a value. This allows you to access values using a specific key rather than an index. The size of dictionary is also dynamic, so you can add, remove, or modify key value pair during executions. For example, you might use dictionary integers in string, as in the example here. You can use the 001 with the employee name 1, 002 with employee name 2, 003 with employee name 3 to store the employee ID and their corresponding names. Dictionaries are perfect when you need to store related pair of values that are accessed by a unique key. So, in summary, arrays are great for fixed collections, lists offer flexibility with dynamic size, and dictionaries are ideal for storing related pairs of data. By understanding the strength of each collection, you can choose the right one for your automation need. Next slide is indicate how to define an array and how to access the element within it. To define an array, you simply specify the data type, followed by brackets and the array name. For example, you could define an array of string like this with the name of our split name, and for the element, you can set it at Michael, Daniel, and Alex. This will create an array called split name that holds three string values. Now, to access an element in the array, you use the array name followed by the index of the element in square bracket. For example, R split with bracket 0 would return Michael because the array are 0 index. And you can change an element in the array as well by assigning a new value to a specific index. For example, you can set our split name at the position 1 to Sarah. So with this simple syntax, you can easily define and manipulate array in your automation workflow. And below here is the other method we use with array. To properly initialize list or dictionary, there are two essential steps: declare the variable and assign the initial value. For example, let's look at initializing a list of strings. First, you need to give your list a name. Select the type of the list as in image and specify T as string. This will tell the system you are creating a list of strings. After declaring the variable, you will use the assign activity to set the value. For example, you can set it to new list of string to create a new empty list. This will set up your list and ready to have value add to it later on in your automation process. In next slide, we'll demonstrate how to manipulate a list or dictionary. First, we can add to collection, which allows you to insert new items into an existing list or dictionary. This is helpful when you want to dynamically build or update your collection during automations. Next, you can clear collections to remove all items in a list or dictionary, essentially resetting it to an empty state. This is useful if you need to start fresh and ensure no old data persists. And we also have the ability to check if an item exists in collections. These operations check whether a specific item or key exists and return true if it does and false if it doesn't. It is great for validations before performing further actions. Finally, you can remove from collections. These operations allow you to remove a specific item from collections, returning true if the item was successfully removed or false if the item wasn't found. And here is all the reference to list and dictionary manipulations. Now, let's explore some other common data type and common operations you might encounter. First one is the datetime types. The datetime type enables you to store information about date and times in a variable. Typical use of datetime variables include appending documents or performing time span calculations. And there are some common methods that can be used with datetime. It will be toString. It will be convert datetime type to string type. Data can be further manipulated, or we can use function add date or subtract to add a number day in integer form to the day of the declared variable, similar for year, month, hour, minute, and second. Now, let's explore some other common data types and common operations you might encounter. First is the data type, which will enable you to store information about date and time in variable. Typical use of datetime variable include appending documents or performing time span calculations. There are common methods that can be used with datetime, with toString to convert a datetime type to a string type. Data can be further manipulated. A day to get the day of the declared variable at integer type, similar for year, month, hour, minute, and second, or you can use subtract on another datetime variable. Output will be a time span type. Next is a file and a folder. It's a basic interaction with file and folder. Get the information about them, create new one, or copy or move to another place, rename and delete. In akaBot, there's some activity related to this topic. First is get file is a return a collection of files at a certain folder. Or create directory is to create folder in a specific locations. With copy directory, you will copy a folder to a specific locations. Also, same function with copy file. Move directory will move a folder to specific locations, similar to move file. It can be used to rename file or folder. Next is to be a delete the folder or file at a specific locations. If a folder contains multiple files, they are all deleted. And last one is the path exists. It to check if a specific path or folder or file exists or not. That brings us to the end of the day 2 training. Thank you for your attention and participation today. We have covered important concepts from basic data manipulations to working with collections and interacting with files and folders in akaBot. I hope you now have a clearer understanding of these essential tools and how they can enhance your automation workflows. If you have any questions or need further clarifications, feel free to ask. Looking forward to seeing you all in the next sessions. Have a great day ahead.